this is William from Visual Components. In this video, I'm going to go over some updates in the Works library. For example, I'm going to show you how to control a robot connected to a servo track. Now to find components in the Works library, go to the ECAT tab, expand Web Catalog by Type, scroll down, and then click Works. So here are the displayed items, and notice some items are marked with V2. That stands for version 2. Now if you want to see and use older versions of items, in the Collections area, right-click, and then click Show Deprecated Components. Notice this updates the displayed items, and there are different versions for some items. Now you need to use the latest version of the Works library if you want to have access to new features. So I'm going to turn off the older versions for some items. So in the Collections area, I'll right-click, and then clear Show Deprecated Components. I can now set up a basic layout. So I'll scroll down just a bit, and I'll drag a Works Task Control version 2 into the 3D world. I'll then double left click a Works Robot Controller version 2, and I can now add and connect a track to this controller. So in the ECAT tab, I'll click Robot Positioners. I'll drag a generic servo track into the layout, and using plug and play, I'll now connect the track to the controller. I can now add and connect a robot to that track. So in the ECAT tab, I'll click Robots. I'll do a generic search, so I typed in generic here. I'll drag in a generic articulated robot version 2 into the 3D world, and I'll connect the robot to the track. Now, before you start using a robot with a track, you need to find out two very important things. First, you need to know the axis the robot will move in the servo track. Next, you need to know if the joint for the servo track increases or decreases when you move the robot along its axis. So to find that out, select a track in the 3D world, click Translate, and in the dynamic toolbar, change the coordinate system to Object. So this will display the XYZ axes in the servo track's local coordinate system. So I can verify now that the robot's going to move along the positive X axis. And now with the track selected, I'll go to the Param tab, and I'll now click Interact and move the joint for the servo track. So notice when I move the robot that the joint, which is called T1, it's going in a negative value. So that means the joint is inverted. So to set up the robot properly, I'll go and reset the simulation, and I'll select the Works Robot Controller. So it's down here. Let me just zoom in a bit so you can see it. And notice there's a sub-tab called Track, and here are your options for controlling the robot on the track. So we have Track Axis, so define its direction, so XYZ. I'll set this to X. And down here we have Flip Joint. So you need to turn this on if the joint is inverted, so by default it's already turned on for me. I'll talk a little bit later about some of these properties, but for now let's go and add some more components and create some tasks. So I'll go back to the ECAT tab, and I'll select Works, and let's go and add some Works Process components. So I'll click Fill here, get a better view. I'll drag a Works Process version 2 into the 3D world, and I'll put it pretty close to the robot to start with. And now let's add another one towards the end of the track over here. So I'll drag another one into the layout. Great. Let's go ahead and create a product and have the robot pick the product from this location here and carry it all the way down here and place it in this component. So in the ECAT tab, I'll click Products and Containers. I'll scroll all the way down, and I'll drag a Visual Components box into the layout. So now I need to create this box, so I'll get its name. I'll first collapse the view of the ECAT, click the Param tab, and I'll go ahead and select all here and copy that name. Now select the Works Process component here. And let's go ahead and make this just a bit bigger. So for task, I already have create selected, and for list of component names, I can go and paste in the box's name and click create task. I can now set up a feed task that I can assign to the robot. So for task, I'll click feed. We don't need to worry about the product ID right now, so I'll clear that out, but I do need to turn on the all checkbox so the robot knows to pick the box. Let's now give a task name, so I'll type in pick place 1 and click create task. Let's now assign the task to the robot, so I'll select the robot controller here, and in task list I'll go and type in pick place 1, and I'll press the enter/return key. And now I need to create a need for the box so the robot knows where to place it. So I'll go all the way down to the end of the track and select the Works Process component here. And let's create a need task. So in task, I'll go and click need. And for list of product ID, you can go and type in the component's name. In this case, I'll paste it because the default product ID is the component's name. So I'll click create task. And And let's zoom out just a bit. And let's go and run the simulation and see how this all works out. Show me the magic. So the robot moves along the track. It picks the box. Yes! It moves further along the track. And it places the box. Great. Let's go ahead and stop the simulation and reset. Now let's talk more about some other options you have for controlling the robot. So I'll select the Works Robot Controller. And I'll go back to that track subtab. So position offset. If you notice, when the robot picks and places a component, it moves to a certain position that's kind of centered on the location. So what you can do is you can actually create an offset on the track for the robot to move to whenever it picks or places a component. So I'll reset the simulation, and for position offset, I'll go and type in 1000, and I'll press the enter/return key. So now the robot should probably move over here when it picks the box. So I'll run the simulation, and yep, the robot moves to that distance. It picks the box, and then it moves as far as it can on the track to place the box. Great. So let's reset. Now for position tolerance, if the robot can reach a pick or place location given a certain distance, then it doesn't really have to move on the track. So this is a way of limiting the amount of movements you have for the robot. So let's go and take away this position offset, set it to 0. And for position tolerance, I'll go and use 300 and press the enter/return key. And let's go ahead and move the component down at the end of the track a little bit closer to the other one. So let's go ahead and use plug and play just to move it quickly. So move it all the way down here. And let's actually move it over here so it's a little bit more obvious. And let's make sure that it's within reach of the robot. So it looks like the robot can reach that. So now if I run the simulation, the robot picks the box, and it doesn't, well, it actually does move a bit along the track, so let's actually increase the tolerance just a bit. So I'll select the robot controller, go back to the track subtab, and let's make this 1000, and press that enter/return key. So now we're in the simulation, the robot picks the box, and it doesn't move in the track, it can simply place the box. Great. Let's reset. Now, when the robot moves along the track, it has a certain type of joint configuration, which is what this property here, robot joints on move, controls. So this robot has 6 joints, so there's 6 values here. So let's edit the robot to move at a joint 0 position on the track. So I'll type in 6 zeros, so 0, 0, 0, 0, 0, so 6 zeros. I'll press the enter/return key. So now let's go and move this component here all the way down to the end of the track again. So now when I run this simulation, the robot picks the box, moves to that joint 0 position, and it places the box. Great. Alright, that concludes the video. Stay tuned for more parts about updates to the Works library. And if you have any more questions, please feel free to visit our community at community.visualcomponents.net. And I hope you have a wonderful day.